An important idea in teaching and using generalizations is context. Now, context for generalization, you can think of as classifying. We implicitly classify certain things as relevant to the generalization. We think, for example, for gravitation, it's all masses. Anything with mass is in the class of things that has gravitational attraction relationships. We haven't entirely figured out what gravitation is essentially and exactly. Scientists haven't yet, mankind isn't yet, but Einstein has some ideas, others have some. We'll see what turns out to be true. But a lot of us think, because we learn of gravitation as something between planets first, because that's where it's most strongly felt. We don't get these other things right away, but you got to remember that gravitational attraction applies to people, in between people, people in the earth, forks and knives, trees, birds in trees, raccoons and birds and trees, water and the earth, everything with mass. So that's a class of things in which we can use ideas about gravitation and the mathematics. Or we might learn that when we get paid working hourly, we get little increments for every hour we work, every extra. You get paid, let's say, an easy example, $20 an hour. 2 hours, $40, 3 hours, $60, 5 hours, $100. It adds up in little increments. And then we find there's other places where this comes up. Add another 45-pound plate on a barbell, and it increases linearly with the weight increases linearly with every 45-pound barbell we put on it. Or every time we add an egg to the pan, the weight increases in proportion to the average weight of an egg. Or if we have simple interest on some money, then the amount we get every year increases linearly in increments. So we see it comes up in all these different areas, and we can generalize to things that have that kind of relationship, that kind of quantitative relationship of adding in a specific, discrete, definite amount or increment every time you go from 1 to 2 to 3 to 4 of something. So our context is strictly delimited, and then we get a better idea of that when we learn about quadratic relationships, exponential relationships, and other things. Learn that linear isn't the only thing. That expands our range of knowledge. But those are some examples of context and how they relate to classification, how forming concepts and generalizations is very dependent on context and classifying certain things and causal relationships. So there's an idea we need to work more. There'd be a lot less confusion amongst our students as to when generalizations apply and how they can use them. We'd all be a lot better off in life, in adult life, work, play, everything, if we had that idea down. But that's going to come from looking at concrete things, not looking at ideas in abstraction from concretes. It's essential to look at concrete, specific things that give rise to the generalization or concept if we're going to be able to do this. So that's a fundamental to classifying correctly, looking at the context. Hope this helps. It's an idea we need to really develop in education more. Help us test better, teach better, be better teachers, be better people in life. Students will be better off. We'd have better assessments. Hope this helps. If you have any comments or questions, criticisms, let me know, and hope you have a great day.